system and some of the features and benefits, but getting ahead of myself, I'll go ahead and cover all this. Me, Director of Sales, started off in this industry back in 1977. New hire for Johnson Controls as a sales engineer, and I've never looked back, been in the industry ever since. It's been a great industry. Worked for manufacturers, worked for contractors. I think I've worn every hat possible in the DDC or the controls industry, from pneumatics all the way through direct digital controls. So, also I've got some cards up here. That's my email address. If you want the presentation along with the notes, please do pick up a card and email me, and I'll be happy to send that on to you. But they will be giving that out, I think, in probably PDF format, which I don't believe includes my personal notes to each slide. So if you want that later on, you can certainly email me and I'll get it to you. Really want to cover the objectives first to make sure that we understand what the objectives are, what we're going to be talking about and learn, so that at the end we can make sure we cover it all. But first thing is really understanding the benefits of control system upgrades, really what kind of things you're going to see as a benefit to your building going from a pneumatic control system up to a true DDC system. Also knowing some of the different ways to convert. I mean, it's not, you don't have to go out and do everything at once. There's lots of different options, lots of different ways and methods to do it. Third, we'll understand some of the advantages and disadvantages of the different ways to convert. Every way that there is to convert, there's some kind of gotcha, if you will. So you have to be kind of careful and do some careful planning, and we'll cover some of those, make sure you have a good understanding of that. And then also, what are the costs, some typical costs, and what are the rewards? What are you going to be able to see for in terms of rewards? And it's not always just the bottom line cost. It's not always just the rewards as you get to going to a full DDC system. So first, to cover the cost of, or the real case for converting. Most of people that have pneumatic controls like it because it's very easy to get parts. You have a pneumatic thermostat that breaks down. I mean, you can actually replace it with virtually any other manufacturer's pneumatic thermostat. You can walk into virtually a dozen wholesale HVAC wholesale houses in town and say, hey, I've got this broken part. Can you give me a replacement? Well, if there's not a replacement that's of the same brand, they can give you one that'll work by a different manufacturer. That's because pneumatic controls all use a very, very standard. In fact, it was probably the first open standard before we got digital controls and finally open standards with BACnet. But pneumatic controls, everything is based on air pressure. It's always a 0 to 20 pound supply air and a 3 to 15 pound control signal. It's virtually the same for all manufacturers. So it's very easy to get parts, brands don't have to match, and you can also easily repair it yourself. Not only is it easy to see the parts and see what's broken, you can actually fix it yourself. Not always the case with digital controls. The problems with pneumatic controls, however, is they do require a lot of calibration and a lot of maintenance. I'm sure if you have a pneumatic control system in your building now, you know that maintenance costs are fairly high. If you have service agreements to maintain it, the people are out there probably 3 or 4 or 5 times a year, tweaking everything and keeping it in calibration. Pneumatic thermostats and transmitters have to be calibrated frequently because they do shift and go out of tolerance fairly quickly. I mean, they can actually shift a couple of degrees just in a 1 year's time frame. So you have to recalibrate them and make sure that they're working right. Also, you have to do an awful lot of work on the supply air system. You have to make sure that you have good, clean, dry air. The air compressor is not pumping air or oil out into the system, and the air dryer is doing its job and keeping the air dry, good, clean, and dry. So there's a lot of maintenance that goes along with pneumatic control systems. So a lot of people wonder, really what is it, the difference between that and DDC? A lot of times you may have heard that you can get trapped with proprietary products. And that certainly is true even today with BACnet and Lawn and some of the other products out there. You can get trapped. And there's ways to avoid that. We'll talk about that a little bit later on. But you can get trapped with that. And a lot of people also always think that converting can be prohibitively expensive. Well, yeah, you can get expensive replacements projects. But if you plan it out correctly, you can actually do a lot of the work yourself and or tackle the parts first to give you the best payback, and then use that payback to actually help, pay for the future conversions of the rest of the system. And a lot of people always think that the payback is too long. Well, I think you have to be really careful when you're talking about payback periods. Most times people always think that a payback period needs to be less than 2 years or 18 months. And that's really based upon outdated philosophies on financing. It's really based on when you had really high interest rates. And today with extremely low interest rates, that payback can actually be quite a bit longer and still fit in with any kind of ROI that you're looking for. And there's also the thing about other things that you may have heard, such as analytics, smart buildings. A lot of times you hear people say that, especially if you go out on the sales floor, you'll see some of the control system manufacturers talking about analytic packages and smart buildings. And really, what is all that stuff? It kind of sounds like a bunch of hype sometimes, but it really isn't. It has some really great paybacks and some really good features for you, and I'll help explain that to you a little bit later on here. Really, so what is the truth? Well, the truth is that any control system can be designed improperly, installed improperly, used improperly, and maintained improperly. And that goes for pneumatic systems as well as DDC systems. If they are not installed correctly, or I should say engineered correctly to begin with, installed correctly, programmed correctly when you're coming to DDC systems, and then probably most importantly, commissioned by a third-party commissioning agent to make sure that it really is doing what it's supposed to be doing. Even DDC systems can be as poor in performance as pneumatic control systems. So just because you go to DDC does not necessarily mean that you're going to actually get an awesome system right out of the box. You actually have to make sure you're doing some things along with it to ensure that it's installed correctly. And a lot of that has to do with finding the correct controls vendor. If you go to the BACnet International website, there's actually a white paper you can download that explains how to best pick a direct digital control vendor and how to qualify them so that they're going to be the people that can install it, engineer it, commission it, and make it work correctly for your building. So that's a free download on the BACnet International website. Some of the problems with pneumatic systems, though, going back to the truth about everything, is, of course, the air dryer and compressor maintenance. You have to really keep up on that. There is, of course, the issue of the constant calibration. That's why you have some fairly high service agreements. But more importantly is there's no operational data feedback. You really can't see what's going on in your building with a pneumatic control system. It could be hot in a room, it could be cold in a room. You could have fans that are supposed to be running and they're not. You could have outside air dampers stuck and you're supposed to be bringing in some outside air, but you don't. Or they may be stuck open and you're bringing in way too much outside air and you're having to heat and cool that and condition that outside air. So in pneumatic control systems, you have no operational data feedback. Also, there's little to no optimization. Now, back in the day when I was engineering and selling pneumatic control systems, they were actually very, very simple systems. And it was because every little function that you did, every logic type of function that you had in a pneumatic control system equated to a part. There was actually a part for that. You had a high-low selector, things like that. And you had to install it, pipe it. It became very expensive to have a lot of optimization. So if you're looking at, let's say, a VAV system, they don't really look at information coming back from the VAV zones to optimize the air handler. To do that would be actually more expensive than a DDC system. In a DDC system, direct digital controls, you really just have your temperature sensor, your valve actuators, damper actuator outputs, and all that optimization logic can be extremely complex because it's just lines of code. It doesn't really cost hardly anything extra. So really, upgrading to a DDC system will save you money. It will save you time. It will increase occupant comfort. Occupant comfort comes from the fact that they have much more advanced control algorithms. In a pneumatic control system, you basically have proportional control only. In a DDC system, it's very easy to do proportional plus integral and derivative. Now, you don't see a lot of derivative control in commercial HVAC systems, but you can use it when you need it in central plant type operations. But you have proportional plus integral control, which gets rid of that offset, pneumatic or proportional control offset that you have in a pneumatic control system. They can also increase your asset value because they will save money. If they're put in correctly, installed correctly, engineered correctly, commissioned, they will save money, which actually turns into both an increase in your bottom line, but also an increase in asset value. So next we'll kind of cover some of the ways to convert, the different types of conversions. We'll get into the benefits and disadvantages, costs, and whatever else we can come up with. Basically, when it comes down to conversions, you have a couple of choices. There are hybrid systems where you keep some of the pneumatics, and that is the actual goal when you do a hybrid system is the pneumatics will stay, and they'll stay for an indefinite amount of time. So a hybrid system does keep some of the pneumatics. Then there's also the total replacement. Now, total replacement could be done in phases or all at once. You might do just part of it 1 year, 5 years later do another part, and so on for a total conversion. But there are hybrid systems where you actually keep some of the pneumatics, and there's some real good reasons why you may want to do that. Some of the hybrid systems where you keep the pneumatics, you actually keep the actuation, the damper actuators and valve actuators. You leave those in place. And some of that is because the valve actuators and damper actuators, if they're really big, let's say if you have a central plant, you have some large 6 or 12-inch valves, and they have some really big pneumatic actuators on those valves, to put that over and convert that to an electric valve could be very expensive. And if you've got a lot of them, that might be a reason why you want to keep those particular parts pneumatic. What you do then basically is you have a DDC controller with an electric to pressure transducer. The electric to pressure transducer then takes and converts that DDC signal output, which is going to be something like a 0 to 10 volt signal, comes to this E to P transducer, which it does have to have 20-pound supply air brought to it, but then it has a pneumatic signal coming out to drive that pneumatic valve or damper actuator. Some of the problems with this is you have to keep your pneumatic control system. You have to keep your pneumatics, your compressor and air dryer, air filters, all that have to stay and continue to run. The real benefits, though, if you do have either very, very large damper actuators because you need a lot of torque, same thing for valves, you need a lot of torque for really large valves, or if you have some actuation that has to be extremely fast, it has to go from fully closed to fully open in just a second or two, and it's big. Well, it's almost impossible to do that with electric actuators. You can get them, but they're expensive. So those are some of the conditions where you may want to go with a pneumatic DDC hybrid, DDC and pneumatic hybrid. There's also some really good ways to start. That would be to, again, start with the central plant. If you're going to do a hybrid system, again, leave the terminal units where you have maybe 300 or 400 or 500 terminal units in your facility. You might want to leave those as pneumatic and put the DDC system in the central plant. You might have a hybrid there, but hopefully you don't have some really big damper and valve actuators, and you actually go to full DDC in that central plant. And the reason why it's a great place to start is that's where, if you have a large central plant, that is where you're spending the most of your money. If you have a bunch of chillers, a bunch of boilers, you're spending a lot of money there, and by optimizing those as much as possible and controlling that as best as possible, that's where you're going to really start getting some good bang for your buck. Problems? No zone optimization. You don't really know what's going on in the rest of the building. You don't have any information coming back from the air handlers. You don't have any information coming back from the individual zones. You can control the plant and the chilled water and the hot water systems much better. That's where it's a good place to start, but you're not going to get that zone feedback. There's another way to do hybrid systems, and that's with smart pneumatic thermostats. This is starting to become very popular in buildings that want to maintain the existing pneumatics. You can actually get pneumatic thermostats today that have electronics built into them. They have a wireless mesh electronics built into them. They're battery powered, so you don't have to bring wire down to them for power. You can actually then, using the wireless mesh, they'll go back to a computer system which will do scheduling on an individual zone-by-zone basis. In most pneumatic control systems, you have one time clock that like turns the whole building on at once, right? Or a whole floor on at once. With these types of systems, you can actually get down to individual zone-by-zone control and scheduling. Yes?
How accurate those wireless sensors?
How what?
How accurate?
They're very accurate. Mainly because they can, the actual temperature sensing part of it is like a thermistor. That information is extremely accurate. Now the pneumatic part of it, the actually doing the control, that is a pneumatic thermostat still, and that does require calibration. But you'll have very, very accurate temperature monitoring, so you'll know exactly what's happening in each individual zone. But the big thing there is you can actually get that information back about what's going on in the zones without actually putting a DDC controller in those individual zones. They're fairly inexpensive and easy to install. They only take 10 to 15 minutes to swap out a pneumatic thermostat with one of these new ones. So it's something you can actually do yourself if you want. But you have to be a little bit careful with the wireless mesh networks. If you understand wireless mesh networks, you can probably install these yourself. If not, you might want to use a DDC contractor that understands that pretty easily, or understands that well. So here's again a picture of what you would have in a pneumatic thermostat changeout. You've got a bunch of your thermostats now are changed out to still a pneumatic thermostat, but it's using wireless mesh to have all the communications come back, all the digital communications coming back from temperature information coming back to the front end, as well as scheduling information coming back. So that's going to come up, go to some kind of transponder that's going to take all the wireless information, convert it over into, say, something like BACnet IP, and then go into the rest of a digital system or a workstation of some sort that's going to do your scheduling and monitoring and alarming on temperatures. Here's a case study that was done for the University of California, San Diego. They actually used the Cypress brand of pneumatic thermostat that has the wireless smarts in it. They did a project there. It's a 112,000 square foot facility that is a mixed use. It's primarily laboratories and classrooms and offices. And in the first year, 27% reduction in electrical, 51% reduction in natural gas usage. The cost of the original project was only $14,600 to go out there and change all these thermostats out, which gave them a huge, with an annual savings of $94,000. The simple payback was 0.2 years. So you can see it's very, very fast payback on something like that. Yes?
Was there any utility incentive figured into that project cost?
There was.
So is that the gross project cost, or is that the project cost after the utility incentive?
That is a project cost after the utility incentive.
So net cost to it.
Net cost. Well, if you get this PowerPoint from me, you can actually double click on this paper, and I'll go right to the paper and you can read it. So the next way to do things is a total replacement. Now, a total replacement doesn't have to be done all at once. You can pick and choose and start off with the overall goal, plan that you will change it all out over a period of a year or 2 or 5, right? But the overall goal is you will do a total replacement. So if you're going to do a total replacement, you're not going to go in and put in EDP transducers and keep some of the pneumatics. Any system that you actually go through and actually change out, you'll do a complete change out from pneumatic to electric and DDC. A lot of people like to start with the air handlers first, the central plant second. And if it is a VAV type system, they'll leave the VAV terminals or whatever terminal units for last. Now, it really depends upon your central plant. If you have a large central plant, you may want to do it first and then do the air handlers. But there's really a number of different ways you can look at it. It really depends upon your building and what you actually have in your building. Nice thing is you can stop at any point if you want, wait for some savings to come in, then use those savings to actually help fund future change-out. So if we're looking at a system here with an air handler alone, let's say you come in and you want to do just the air handlers. Well, what are you going to see? You're going to see a very much improved sequence of operation. It's actually going to have a much more complicated system there. You're going to have things like optimum start along with the scheduling, maybe even optimum stop. Very precise control of the temperature, but probably the most important part of this one is you end up having much better and much more accurate control of the outside air CFM that's coming into that unit. You can actually make sure that the dampers are working correctly, that you're bringing in the right amount of outside air. You can actually do things like put in CO2 sensors and do demand control ventilation and reduce the amount of outside air coming into the building. Anytime you do that, you have very big cost savings because you're no longer conditioning that outside air, while at the same time you're ensuring that you have enough outside air that the occupants are going to be comfortable and have good indoor air quality. Again, great notification of trouble. It's going to tell you things like, well, the mixed air temperature is 70 and it should be 55 based on the damper position and return air temperature and the outside air temperature. Those systems can actually tell you that you've got a problem early on. You also have other great diagnostic tools such as trend logs. A trend log basically just goes out there and samples what all those values are. The room temperature, the mixed air temperature, the discharge air temperature, position of the valves, position of the dampers, and lines all that data up, and you can see, does it all look correct? Is it performing the way it's supposed to? And gives you a good idea that there's something wrong. You can go out and fix it before you start really spending some money in lost revenue on it because of a problem. Other problem, though, if you're going to do just the air handler alone, is no optimization from zones again. So if this is an air handler that's actually feeding terminal units like VAV boxes, if you're doing just the air handler, you're not getting information back from the VAV boxes. But if it is just a single zone air handler where it's providing air just to a single space, the room temperature sensor, the air handler just feeds that one or two rooms, you already have your optimization. Next would be if you do the air handler plus a central plant. Well, now you can actually run the central plant a lot less. If you at least know what the air handlers are doing when they're running, when they need heating and cooling, you can enable the chilled water pumps or the hot water pumps and the boilers and chillers only when they're required. Again, going back to a simple pneumatic control system, those systems are basically enabled anytime it's hot outside or cold outside. It turns them on whether the zone's needed or not. The boiler is heated up, it's pumping hot water around. Same thing with chillers. If it gets outside, usually the pneumatic control system said if it was greater than 72 degrees outside, it would start the chiller and chilled water pumps, whether it was required or not. So if you have at least the air handler and central plant, now you're going to be able to really optimize the central plant as well. But still, no optimization from the zones if it's something like a VAV box type of application. So a total replacement is really probably the best, of course, if you have the funds to do that. You can do things like if it's a VAV job, project with VAV boxes and an air handler, you can bring information back from the VAV zones about how much air they need. If they don't need enough as much air, you can actually lower the duct pressure on the air handling units. And when you lower the duct pressure, it's a exponential curve as far as the amount of energy you're going to save from the fan energy. You can also bring back information in the VAV terminals about they have enough air, but they still can't maintain temperature because maybe the discharge air temperature is too high. It needs to be a little bit colder. But conversely, it can also say, I've got my airflow and I'm already having to go all the way down to minimum airflow, and yet it's still, I don't need as cold of air. So you can actually raise the discharge air temperature in your air handlers, actually balance that so that you're running at as low as duct pressure as possible and as higher air temperature as possible in the air handlers, and still having all your VAV boxes satisfied. So those are some of the things that you can do with DDC that you really could not do with pneumatic controls. If you were to try to do that kind of full optimization with pneumatic controls, the cost would have been 2 or 3 times what a DDC system would be. Plus, you'd have a bundle of tubes coming back from every zone VAV box this big, It really would not be practical. So really, more information is better. You get all this information back with a full DDC conversion. Now you can also start using some of that data analytics we mentioned earlier. Data analytics are great for automatic proof of operation. Some of the systems out there today will look at the temperatures and tell you that, let's say, the mixed air temperature versus the return and outside air temperature in the damper position don't match up. Based on the damper position, the mixed air temperature should be 65 and it's 55. So they'll actually tell you an alarm right up ahead of time that they don't match. The damper's stuck, basically. So they can give you some very good actionable information about what's happening. Also, data analytics are great for getting information to the tenants. If your facility is a leased tenant space, you can actually put what's called a kiosk down in the lobby area and tell people information about what's going on in their building. Our building today is using less energy than it did last year before this. It's been proven, lots and lots of case studies, that if you show people how much energy is going, they're using and spending in their buildings, they'll actually use less. They'll do things like turn the lights off because they start to become conscious of the fact that what the energy usage is in the building. So it's a great using that analytics and not only for the maintenance of the building, but also pushing that information out to tenants is a really good cost savings. Now, I've been in sales for a number of years, and people always ask me, well, how much does it cost? And I always say it depends. And people always, I'm sure they kind of get that glassed over looks, like, oh, here's a salesman, just doesn't want to tell me how much it costs. But it really does depend. I mean, there's a lot of different variables in there. There's the location. If this project is at New Mexico, where you have very, very low cost of electrical installation, or is it in downtown Manhattan in New York City? Is it a high-rise building? A high-rise building you have added costs because you have to actually figure the downtime for the construction crews for riding elevators. You wouldn't think that, but it actually does add up. Is the building occupied, or is it a building that I can go in there and tear up the ceiling and put all this new stuff in, or do I have to work at night only because it's an occupied building? Those are going to drive up the costs. Also, the time of year. If you want to do this just during the deadhead middle of the summer, that's also the big construction time. Especially in hot areas. That's when the service crews and everybody's out there trying to fix broken chillers and things like that. So if you try to schedule it right during the middle or the peak of the construction cycle, you're going to pay more. So again, that's another variable that's in there. And of course, how much is done on the project. Always vary it. But I will talk about some pricing. When you're looking at hybrid systems, certainly if you're going to leave the pneumatic actuators there, transducers are about one half the cost of an electric actuator, typically. When you factor in installation, material costs, and everything else, it's about half the cost of an electric actuator. But you still need to maintain your air compressor and dryer. Typically, they run anywhere around $1,000 per terminal unit if you're going to do that. Now, that's a fully engineered, installed, programmed, commissioned per cost. But that's a real typical. It does vary anywhere from $1,000, maybe even $2,000 or $3,000, again, depending upon the location. If it's a smart pneumatic thermostat change out, some of that you can actually do yourself. You can work with the contractor and do it yourself. But those typically are run anywhere from $500 as a minimum up to $800 and more per terminal unit to actually change out the pneumatic thermostat to a wireless mesh smart pneumatic thermostat. That will include all the front-end costs for programming a workstation and everything else. You're looking at full DDC system costs. A typical air handling unit or rooftop unit, RTU, anywhere from $35,000 to $5,000, $6,000, $7,000. Again, it depends upon what you have on your air handling unit. Is it a really big air handling unit with big valves? Do you have humidification, dehumidification? You have smoke detectors, all that kind of stuff that need to be in there. That starts to increase the cost, but it's very, very typically somewhere in the $35,000 to $5,000 range. Central plant, here you're going to see some really wide variances depending upon the type of central plant, how big the valves are and things like that, how much equipment is in there. I've seen them as low as $5,000 because all it was a couple of pumps, one boiler and one chiller, right? Those are not very expensive, but they can easily be $20,000, $30,000 depending upon how much conduit has to be installed, things like that. So the big cost items there are really the large valves. That's probably one of the biggest cost drivers on it, plus how much conduit and wire has to be installed. Okay. If you're looking at terminal units, such as VAV boxes, they're going to range anywhere from $1,000 to $1,500 per terminal unit to go from straight pneumatic to full DDC. Again, it's going to vary quite widely depending upon the location. Is it something that we can do during the evening time only, or can I do it during normal construction periods? Probably the highest cost drivers on doing this is the installation of getting up into the ceiling spaces. Is it a hard ceiling or is it a drop ceiling? The drop ceilings, it's very easy. Somebody move a ladder around, pop the ceiling up, and continue moving on. They can also get communication wire between all the different zones is much easier to pull in a drop ceiling type. But if it's a hard ceiling, it gets really, really tough. Also, if your walls are concrete and the existing pneumatic system was just put inside the concrete, well, now it gets very difficult to put a electronic thermostat or electronic temperature sensor in the wall and get that wire up, because you may not have an easy way to get up the wall without putting some kind of external wiring on the wall. And of course, off-hour installation is a big one on terminal units, because that's where your workplace, the tenants are, the employees may be, so that if they can move around and you can do the construction during regular office hours, that's much better. You're gonna have much better pricing. So some of the biggest challenges is the room temperature sensor cable. Also, the power for terminal units is also something that people often forget when you're talking about VAV terminal units. Now, if it's a heat pump and you have a water source heat pump building, you've already got power at the heat pump to drive the new digital controls that are going to be there. So the power and transformer that's at that heat pump is very easy. You can power up that DDC controller. However, in a VAV box project, you may not have power at the VAV boxes on an old pneumatic control system. So in that case, power has to be brought around to them. So it's not only just the cost of the controller and a room sensor and maybe some communication, but now you have to have big panels with transformers in it feeding all of these VAV boxes, because it wasn't installed initially that way. So I think that's a lot of times people forget about the power to the terminal units. There is. You can do power over Ethernet is starting to come around. The thing is that most people don't use Ethernet for terminal units. It's going more that direction, and I would say probably in the next 5 or 10 years you're going to see the industry is probably going to shift to that. But currently most, certainly in BACnet and even other open protocols, the communication wire is usually a twisted shielded pair. Talk about a project that actually was a conversion project. This was a project, it's actually a case study that you can see on the BACnet International website. There's a bunch of case studies on there that you can download, and this is one of them. It was the TDK Headway Technologies building in Milpitas, California. Headway, basically what this facility is a 100,000 square foot production clean room. And Headway, what they make are the read-write heads in hard drives. This is one of 3 facilities in the world that makes the read-write heads for hard drives. So they're basically making large silicon wafers. I think they're using 10 to 12 inch silicon wafers. And it takes that silicon wafer anywhere from, it takes it typically about 2 weeks to go through the whole production process, through all the different clean rooms and all the production process. The problem with that is they can't shut down anything. that facility has to be running 24/7, 365. It never shuts down. It doesn't shut down for Christmas. It doesn't shut down for New Year's. It shuts down for nothing. So it became a very, very difficult conversion process because they could not turn off an air handling unit for more than just a couple of minutes to go from pneumatic to digital. So the panels all had to be built, the wire all pulled, everything ready so that they could just very quickly change over some of the end devices. Up to, they had 20 air handling units that are outside air units. There was 52 air handling units that were circulating only. They had about a dozen different boilers and 6 chillers, and they were thinking they were going to have to add more boilers and chillers because a mechanical engineer came in and said, yeah, well, your temperature control problems is you don't have enough capacity. Actually, after the conversion process was done, they went from, I think, a dozen boilers down to 6 boilers, and they actually were able to turn off a couple of chillers. And by doing that, they dropped their power from 5.4 megawatts to 4.4 megawatts, which in the very first year resulted in $800,000 worth of energy savings alone in gas and electricity. Plus, Pacific Gas and Electric, after the job was done, said, hey, you guys did such a great job. They gave them a big rebate check, $633,000 rebate check. So this project went from being over $1 million, but it had a payback period in less than a year. So you can actually do that if you do very careful planning, but it took a very, very large amount of planning up front because this is a project that could not be turned off. I think it's important to look at payback, what kind of payback that you're going to have in a system and where you might want to find money to pay for this as well. So I'll cover next something about some of the rebates and grants that you can get. What is the acceptable return on investment or payback? And some of the other things that you may be missing when you're talking about energy savings. Really, what does it do to the bottom line? Where is that bottom line increase or decrease in the bottom line? Where is it coming from, right? It's probably one of the best places to go to find out information about local, state, federal, and utility rebates and grants are these 2 websites here, the energy.gov/savings and desireusa.org. Desireusa.org is probably one of the best ones that I always use when I'm doing it in a sales situation because it'll show me all local utility, whether it's a gas or electric, any rebate programs that they may have, It'll also show all of the local state and federal rebates and grants that you may be able to get on it. So it's a great website if you want to find out what is available to help pay for this up front without actually, taking it out of your cash flow, right? Again, I think it's important to realize that not to look at just simple payback. Simple payback periods focus strictly on returning the capital. It might say that the payback is a 1.5 year or 2 year payback. But looking at simple payback also ignores the fact that once that 1.5 or 2 years is up, it continues to give you money after that. You're still getting income after that, right? It doesn't stop saving you money after 1.5 or 2 years. So it only focuses on how fast does it take to return the capital. And again, most people today think of they always want to say it should be 1.5 year payback, but that was really based on when the cost of money is around 10%. And cost of money today is quite a bit less than that. It's usually less than 2%. So if you're actually looking at true return on investment, it tends to actually match up if you actually do all the whole math all the way out, if you're going to end up borrowing money to put this in. Some of the other things that you don't really think about is in tenant, if you have a speculative lease space building, is the actual increase in tenant retention. There's been a whole bunch of different studies. If you look at the PowerPoint and you have the notes one, I have there's a couple of different studies was done. One of them was done by C.B. Richard Ellis, where actually they showed quite a bit of increase and lower vacancy rate in buildings that were, in this case, green buildings, but direct digital control systems typically can be very much on the green side of things, because you're actually be decreasing your energy costs and increasing air quality and thermal comfort. And a lot of times that also increases employee performance. This is one that's highly nebulous. It's very difficult to quantify this. But again, if you look at the PowerPoint presentation in the notes, I have references to 4 different studies that have been done on this, where putting in a DDC system and correctly and controlling both the temperature and indoor air quality, bringing in the correct amount of outside air, reduces sick time, decreases healthcare costs. And when you take that, you take the actual number of hours per year that turns out to be, and you compare that to the cost of the employee, they actually adds up to almost $20 per square foot per year on a building, which is far, far above just your energy savings. But it is very difficult to quantify. But there are, like I say, there are some really great studies out there. So it's not only just the bottom line on your natural gas or your water or your electric bill, but you will see a big savings on other areas of your operation. All right. Lastly, here is the increased asset value. Most people don't really realize this, but yeah, you might be able to save $100,000 a year in your electric bill. Maybe your electric bill and your whole utility and energy bill was $1 million, and you're saving $100,000 per year with this new DDC system. Well, if you've got a cap rate of 10% on your building, that's $1 million increase in asset value. So that's another thing that a lot of people don't think about when they're looking at, should I increase or should I actually go out and put in a DDC system? A lot of times I hear a lot of property managers say things like, well, we're only going to hold on to this property for a short period of time. We don't want to actually go in and put a bunch of improvements into it. But they're missing this point. They can actually increase their asset value. So, 2 or 3 or 5 years down the road, and they want to flip this property, by putting in the system, they can actually spend $200,000 or $300,000 putting in the system, but have an increased asset value of $1 million. That's over and above the actual savings they're going to have during that 2 to 3 years. So there's another really great reason to upgrade from a pneumatic to digital system. There's also some really good financing options. I had the other website up there that talked about grants and rebates, but there's also a bunch of financing information you can find on it on the Energy Star website, energystar.gov. It's kind of hard to find, but if you go to Home and then Buildings and Plants and then finally Financing, you can actually find a section in there that has a whole plethora of information about energy efficient projects, ways to find money to help finance that through the government and other ways. It also has a really great cash flow calculator in there too. So some of the final thoughts here. I really think that the phased approach is best, especially if you don't have a lot of money up front. Have somebody do an energy audit on your facility, find out where you're spending the most amount of money right now, and attack that one first. It might be the central plant, it might be the air handler, it might actually be the terminal units. But find out which section where you're actually spending the most amount of money. That's going to vary depending upon your building type, right? But approach and tackle those first. You can bid out each phase in a phased approach. And BACnet actually favors that, because BACnet, you can actually have multiple vendors bidding different products, right, by different manufacturers, but they're all BACnet. So they actually can communicate and talk to one another. So you can actually come in and do the air handlers with DDC systems by one vendor, one manufacturer, and the terminal units might have DDC controls by a different manufacturer. But if you're using BACnet, they can all communicate, all the information can be meshed. You'll actually get all that optimization, and you're getting the best price in each of those phases. Remember to really think about the long-term benefits, though. It's not simply the simple payback. There's a lot of other things that you need to really consider there. And also, careful installation planning, I think, is very, very key. Look at the TDK Headway project. They spent several months trying to figure out the installation, how they were actually going to do that, and came up with a way to do it, and they didn't have to have the downtime. Right? So it's very, very key to actually have good, careful installation program. Talk a little bit more about the BACnet advantage. BACnet was created and is still controlled by ASHRAE. And ASHRAE, the ones that control all the rules about air handling units and set all the codes for your building as far as indoor air quality and air handling units and that sort of thing. It's been around since 1995, and since then there have been over 50 addenda actually improving the BACnet standard. All of that's backwardly compatible, so the stuff that's out today still works with the BACnet controllers that were put out in 1995, but they continue to improve it in areas that have to do with building interoperability. So actually you can tie your chillers, your boilers, your lighting control systems, your access control system. You can tie all that together now using BACnet because they continue to evolve the specification to control, to take advantage of new technologies and new ways to actually control a building. So it's a great standard and allows all those products by different manufacturers to communicate together. And if you go to the BACnet International website, there's a whole bunch of different success stories in there, broken down by building type. So it's very easy for you to find a building type that matches your type, your building, and see what these people did. How did they do it? What were their success stories that they have? Must be over 40 or 50 different success stories that are listed there. And again, you can find the one that matches your building. So really the advantage of BACnet is it's extremely easy to expand. And some of that is because it is what's called a discoverable system. It has automatic discovery. So you can actually take a computer and tie it in there by any manufacturer and take a look, and it'll show you all the devices that are out there that are BACnet by different manufacturers. You can have VFDs, you can have air handling units by different manufacturers, you can have terminal unit controls by a third manufacturer, and in BACnet they'll all expose themselves and say, this is my address, this is who I'm made by, and this is all the information I have available. So BACnet is a really great protocol to use because it is very easy to expand. You can do little bits and pieces. It's very easy to add controllers in the future, one controller at a time or a whole wing at a time, and it does allow for bidding out different phases if you use bidding process to with multiple manufacturers. So cover some of the learning objectives to see if we actually hit them. The first one was better and more data. Certainly that occurs when you go to a DDC system because you actually get all that zone information coming back. You can actually have data analytics to tell you when things are wrong, when the things are right, when they're working right. You certainly will get much better temperature control. You'll have better satisfied occupants because now you can actually know that you're controlling things the right temperature, you're having the right indoor air quality before they even tell you that there's a problem. In fact, there's been lots of studies that have shown that tenants will not even tell you that they have, that the temperature is bad or the indoor air quality is bad. They just think that that's the way it is, right? And they accept it. But that actually does lead to lower or higher vacancy rates. Certainly savings in both utility and maintenance and manpower, your own personal manpower for maintaining a building, and lastly, the increased asset value. So what are some of the ways to convert pneumatic to digital? So you may want to, pardon? Hybrid system, you bet. Hybrid systems, keep pneumatic actuators, or smart thermostat replacement is one of the ways you can do it. You can do just bits and pieces and just leave the rest of it pneumatic, right? And what was the other way? Phased, but a complete replacement. And a lot of times that is phased. It can be done all at once or phased. But you're not going to be going in there and putting in smart pneumatic thermostats if your overall goal is to have a complete DDC replacement. So you really want to understand which direction you're going to go and up front. What are the benefits of both? So what are some of the advantages and disadvantages of, let's say, central plant only? Everybody remember what the advantage of, if you're going to have an advantage of central plant only, what was the advantage? Especially if it's a big central plant. Yeah, big central plants where, let's say you have a campus or a large building and virtually all your heating and cooling energy is coming from that central plant. That's where the biggest bang for your buck is. The disadvantage of central plant only was what? Anybody remember? No feedback from the zones, right? You don't know what the air handlers are doing. You don't know what your terminal units are doing. If you're doing air handling units only, what were the advantages and disadvantages? Outside air control, especially, that's a great advantage on air handling units. One of the biggest wasters in most buildings today is probably scheduling, number one. Most buildings, you think that they're scheduled, but they're not. But it's conditioning that outside air when you're bringing it in. So you want to make sure that A, you have enough outside air that the tenants are not uncomfortable, but also not too much outside air, because that's where you're wasting energy. And then the full complete replacement. Well, probably the only disadvantage is it's probably the most expensive up front. If you're looking at upfront costs, it has probably the highest upfront cost. But it also has the biggest payback, not only in terms of energy and utility cost decreasing, manpower for maintaining your building and maintenance, but also improved tenant retention and employee performance is going to go up as well. So that's probably the biggest advantage and disadvantage of all those. And what were some of the costs and rewards of converting to DDC? Well, I don't really have any answers there. Oops. I don't really have any answers here to throw up, but we have just a couple of minutes. Any questions about the costs and rewards for converting to DDC? Yes?
Is there any government grant for the upgrade?
Excuse me?
Is there any money outside the government, like stimulus money or any other?
Well, lots of utilities. I'd say most of your utilities, your public utilities, have rebate programs and grant programs to do this.
I hear where we are from Florida, we have power companies that from next year, they won't be having any money.
Well, the whole utility thing does depend upon the state and the political ramifications you have. For example, if you go to Alaska, Alaska's got an enormous amount of energy to maintain the interior comfort in buildings because of its you go to Fairbanks, it's hot in the summertime in the Fairbanks, and it's extremely cold in the wintertime in Fairbanks. They spend a tremendously high amount of electrical and gas and everything, but their utilities are they say themselves as the business to make money, and they also don't have a problem of having that they have to build new power plants. They have plenty of power to supply what they have. So in Alaska, they're actually discouraging any kind of cost savings. There's virtually none that you can get from the utilities there. But you go to some of the other states that have a shortage. You go to California, let's say, for example, where they have a real shortage. They can't build new power plants in California because of regulatory reasons. And there's all kinds of rebates and grants and everything else to get people to reduce power because they don't have enough, right? And they really can't build new energy plants. Okay, that's pretty much it. So thank you. Again, my card is up here. If anybody would like to have this presentation, I'd be happy to email it to you. All right, thank you.